Welcome. Today we're talking about kites. And these are not the fly in the park kind of kites. These are geometric kites. So first, what is a geometric kite? Well, it does kind of look like a fly in the park kite, just I drew it on its side. But if you've been following along in order with this playlist, then we've been talking a lot about parallelograms, quadrilaterals with two sets of parallel sides. Number one thing to remember about a kite is that it is not a parallelogram. A kite does have four sides. It is a quadrilateral, but it does not have any parallel sides. A kite is a quadrilateral that has two sets of congruent sides, but they're the ones next to each other. They are consecutive congruent sides, not opposite. Now, what else happens in kites? Here we have a kite pictured, but let's look at the diagonals. If you draw one of the diagonals, it cuts the kite into two isosceles triangles. This one happens to cut it on a left triangle and a right triangle. But remember, isosceles triangles have some things congruent. We'll be working with that. What else happens in kites? If you draw the other diagonal, it cuts the kite into two congruent triangles. You can already see we have two sets of congruent sides marked. Then the diagonal we just drew is our third side. So these triangles are congruent by side, side, side. But something else we can look at when we draw both diagonals, they're perpendicular to each other. So there are all kinds of things that you can be asked about with a kite. Let's go ahead and try our first one. This is a kite, ABCD is a kite, and I want you to find one angle measure and then one side length. ABD is 50 degrees, that's up at the top. I want to know how big angle ADB is, that white one marked at the bottom. Now remember, that diagonal that's drawn there, it cuts the kite into two isosceles triangles. So the isosceles triangle theorem says that the base angles for that triangle should be congruent. So if ABD is 50 degrees, then ADB is 50 degrees also. Then when we look at CD, that's a side length. So we have to consider what we know about the sides of kites. And we know that those consecutive sides, basically on that other isosceles triangle, are going to be congruent. So if BC is 7.5, so is CD. Now let's look at another one. We've got some more angles we're going to find. So we have one angle marked at the very top and one of the right side angles marked. And the thing to remember here, when we look for angle ADC, so that's the one at the bottom, is that the triangles that are split by this diagonal, there's a top triangle and a bottom triangle, they are congruent. So their corresponding parts are congruent. So if that very top angle is 110, this very bottom one, since it's a reflection of the other triangle, will also be 110. Then angle ACB over on the right, that one, again, we have congruent triangles. It's just reflected. So if the bottom angle is 35 degrees, then the top angle will also be 35 degrees. So here are some bonus properties about our diagonals that we've just kind of experienced. One set of the opposite angles is going to be congruent. Not both sets, because that would make it a parallelogram. But one set is congruent. The other set is bisected by the diagonal. So you see the 35s there? That originally, in the original kite, was a 70-degree angle that was bisected when we drew the diagonal. So to summarize some different things that we can do with kites, just by definition, they do have two sets of congruent sides, but they are consecutive sides, not opposite sides. The diagonals do end up being perpendicular. One set of your opposite angles are congruent, but the other one gets bisected by the diagonal that connects them. So thank you for joining me for this talk about geometric kites, and I'll see you next time.